We're now going to talk about permutations and how we count permutations. And remember that a permutation is when we take an arrangement of n items in a fixed order where no item is used more than once. And so this is what we're talking about. And the specific order is important. How they relate to each other, which one you do first, which one you do second, which one you do third, that all matters in a permutation. So order absolutely matters. And so we're going to look at some examples. Let's start with this one and just see if we can figure out how this works. So how many different ways can 7 books be arranged on a shelf? So we have 7 different books, and then we've got 1, 2, 3, 4, 5, 6, 7 slots. 1, 2, 3, 4, 5, 6, 7. So our first decision says we have 7 slots to choose from, so that's 7 possible choices. And that will mark out, let's suppose that we just put the first book there. The second decision, which is the second book, has only 1, 2, 3, 4, 5, 6 slots left, which says there's 6 different choices. And let's just say that we take out this one. And it really doesn't matter, I'm just trying to illustrate the point here. Our third decision, there's 1, 2, 3, 4, 5 slots, and yes, there is a faster way of doing this. And so let's suppose that we pick the last one for that book. And for the fourth decision, you'll notice that there's 1, 2, 3, 4 slots, which means there's 4 possible choices. So we take out that one. The fifth decision has 3 slots. 1, 2, 3. 3 left over. Let's take that one. The sixth decision has only 2 slots. So there's 2 choices. We take out number 6, which means our 7th decision, no matter how we do this, there's only 1 slot left on the bookshelf, which means there's only 1 choice. This is a good fundamental counting principle question. So we get 7 times 6 times 5 times 4 times 3 times 2 times 1. And notice that this is the definition of our permutations. And so to count permutations, all you really need to do is take n factorial. If you have n items in a specific order, there are n factorial permutations. And that will always be the case. So in this particular case, we get out our calculator, we do 7 times 6 times 5 times 4 times 3 times 2. It says there are, and I'm not going to times by 1 because that doesn't change it, but this says that there are 5,040 different ways of sorting that shelf with 7 books. So let's look at another example. How many different ways can 25 students be seated in a classroom with 25 seats? Well, this is really easy. Since we're filling every seat, it's just like the bookshelf. This is simply a permutation question, so there are 25 factorial different ways. So we're going to get out that calculator again. We're going to do 25 times 24 times 23, 22, 21, 20, 19, 18, you can see this is getting very large very quick, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. That's how many possible choices there are. And I'm not going to bother writing that out. That just gives you the illustration of how many permutations there are, and it's n factorial. And so that's all we need to know about permutations. If you use everything every time, then it's just that number factorial, and you will correctly have the number of choices available.